Sometimes it takes and sometimes it doesn't. All right. We'll go from current slide. Okay. I guess we won't get started. Oh, here it goes. There we go. We are now recording, and it finally has come up. Just a couple of small announcements. Remind me your name. Huh? Decima? Is that what you said? Okay. Okay. All right. Anyone else come in since the call roll? Okay. The only announcements, and this isn't very major, but I just want to let you know. Is it Essence? Friday was sort of a disastrous day. So just about everything I planned to do on Friday, I couldn't do. There was a problem getting in the morning, and then the dean had called a meeting, and I had to get ready for it. And then lots of people were coming by, and then the meeting was supposed to be no more than an hour and a half. It went forever. So I got almost zero done. I got all your papers graded because you were the first ones on the stack, but I didn't get anything entered at Blackboard. So if you're looking at Blackboard and you turned in a paper already, I've got your grades. You can come see what you did on your quiz. There's what is it? 1, 2, 3, 4, 5 have turned in quizzes already. You can see it. I just don't have them on Blackboard yet. So maybe, can't remember if I got any of the early ones in there or not. Okay, remind me your name. Say it. Martin?
Marcus.
Oh. Marcus, right. Okay.
Justin.
And?
Justin.
Say again?
Justin.
Johnson. Okay, great. Thank you. Kadarius, right? Okay. All right. Anyone? Anyone else come in? Since the call roll. Okay. I was just telling the others who were here, everything that had been turned in, you turned in last week, I have graded, but I don't have it all on Blackboard. And so Friday just turned out to be a disaster. Then we were out of town this weekend. I thought I would get things caught up there. It didn't happen either. So it was a pretty tough weekend to get anything really done. Starting on Friday, it was miserable. Okay, any questions on anything we've covered so far? Wanted to wrap up 3.7 today because goodness gracious, this thing's slow. On past final exams, we have a departmental final exam. On past final exams, I've seen problems more like this section than on the previous section. So I wanted to go a little bit deeper into these. So here's the next. If there are no questions, I think we're on example 5, top of page 168. 9a times a plus 1 is equal to 4. And get your name, please.
Chris.
Huh?
Chris.
Chris. Got it. Okay, good deal. Thanks. Okay. Name, please.
Sheffield.
Huh?
Sheffield.
Sheffield. Okay. J, right? And?
Benny.
Benny. Okay. That's JT, right?
Yes, sir.
Okay. Anyone else come in since the call roll? All right. Here's the problem. Example 5, top of page 168, section 3.7. Looks like they did us a favor here, right? They've already factored the left-hand side. We good to go? What's wrong with this picture? Yes, it doesn't do any good to have it factored on one side and the other side not zero because of the zero product principle. So guess what we got to do? Second? You do have to do that, but actually I'd say before I did that, I would distribute, not factor, it's already factored, have to unfactor it, distribute the 9a across the parentheses, then subtract 4, and then refactor. So, what is the result of distributing? 9a squared plus 9a minus 4, there he did it all at one step, is equal to 0. So, everybody see that? Now, if you don't like skipping steps, don't skip steps. You know, do every one, okay? But if you see it, you can go with it. All right, does this look sort of familiar? Might you think that's a perfect square trinomial? No, why not? That 4 is not a positive. Remember, with a perfect square trinomial, that's a perfect square, fantastic. 4 is a perfect square, but minus 4 is not a perfect square because you can't have a negative number as a square. So no, this is a perfect square trinomial, so how would you try to factor? And you can do trial and error or AC method or whatever you'd like. What would you like to try? Trial and error. How would you try? 3a times 3a. Then where do you look next? Sign of the last term is negative. That tells you these two terms are different. Okay, and what would that, which order you want them? Plus and minus. Okay, we'll do it that way. What's a possible factorization of 4? 2 and 2. Let's try it. I don't think that'll work. Why not? This is the sum times the difference of the same two entities. Guess what? That would be the difference of their squares. You have a different square here, but you got a middle term. So I don't think that one will work. You can try it, but it won't work. So, okay, let's try it. 3a times 3a, 9a squared. 3a times negative 2, negative 6a. Positive 6a, that adds to 0, not 9a. Okay? So therefore, we need to change the numbers. What might you try next? Set 1 and 4? Okay, let's try 1 and 4. Okay. We'll do 1 here and 4 there. All right. Now let's take a look. 3a times 3a. 9a squared. 3a times negative 4. Again. Negative 12a. Plus 3a would be negative 9a. Close but no cigars. It was a plus 9a. Right number, but wrong sign. So guess what we do? Change the signs, okay? So we'll make the first one the negative and make the second one the positive. Okay, now we'll try it again. This is why they call it trial and error. 3a times 3a. 9a squared. 3a times 4. 12a. Minus 3a would be a plus 9a minus 4. Yes, yes, yes. Okay? Are you through? No, we just factored it. We got to solve it. And what would that be? What do we do next? Say each of them equal to 0. 3a minus 1 equals 0. Or 3a plus 4 is equal to 0. Okay? Because the only way you can get two entities multiplying to be 0 is if one or the other of them has to be 0. So on that first one, what do we have? What do we do? Add 1 to both sides, and that gives us 3a equal 1. Divide by 3. And that gives you a is equal to 1/3. And on the other side, other equation, subtract 4 from both sides, and that gives us 3a equal -4. And divide by 3, and you get a is equal to -4/3. I can just tell this is going to be fun to check, isn't it? What's 9a times 1/3? 3. Times 1/3 plus 1. How many thirds is 1? 3/3. So 1/3 plus 3/3 is? Say again? 1/3 plus 3/3? 1 plus 3 is 4/3. And you have 3 times 4/3 is 4. Yes, we got it. Okay, let's do the next one. 9 times a -4/3. 9 times a -4/3. 3 will go into 9. 3 times -4 is -12 out front. So hang on to that one. What's -4/3 plus 1? 1 is how many thirds? So that'll be a -1/3. So you got 12 times -1/3. -12 times -1/3 is negative times negative, positive. 12 times 1/3. 1/3 of 12 is 4. Yes, we got it. Okay. And he thought we were swinging golf balls in here when I said 4. Never mind. Okay, name please?
CJ.
TJ. Okay. CJ. So C. Okay, got it. All right, any questions on that? Sometimes checking them's harder than doing the problems almost. All right. Another one somewhat similar is this one. Solve this. X minus 1 times x plus 9 is equal to 11. How do we approach a problem like that? This is example 6, page 168, section 3.7. How do we approach a problem like that? Looks pretty good. It's already factored for us, right? But what's wrong with it? Not equal to 0. So guess what we got to do? Well, actually, you fool it. You got to unfactor it, okay? Okay, and that would give you x squared plus 9x minus x minus 9 is equal to 11. And what does that give us? X squared plus 8x minus 9 is equal to 11. Now what? No, this is a quadratic. With quadratics, we try to, and anything 2 or higher is the maximum exponent. We try to get everything on this side, and what on that side? 0. Nothing. Okay, 0 on that side. So what would we do? Subtract 11 from both sides, and that gives us x squared plus 8x minus 20 is equal to 0. All right, guess what we do to this one? What's that? Factor it. If it's factorable, we don't know that it is, but let's try. What's the only possible factorization for x squared? X times x. That's easy. Where do we look next? Sign of the last term, and that's a negative. That tells you these two signs are? Say again? Different. So one's a positive, one's a negative. Okay? Now, we're looking, this has a coefficient of 1. We like those. So now all we need, because we have different signs, we need two numbers whose product is 20, but whose sum is, whose difference, because they're different signs, difference is 8. 10 and 2, and which one wins? The plus sign. The 10 gets the plus sign because it's the larger number. And 2 here. All right? I think we can check that and see it works. What does this tell us? Say again? Oh, you're checking it? Okay. You can check it if you want to. X squared minus 2x plus 10x we give you plus 8x and minus 20. So that worked. Okay, so where do we go from here? Are you through? Okay, yeah, you say each of them equals 0. X plus 10 equals 0, or x minus 2 equals 0. And what do you do with the first one? Subtract 10 from both sides, and that gives us x equals negative 10, if I could write, and over here, add 2 to both sides, and you get x equal 2. All right, that won't be too bad to check, I don't think, sort of big numbers, but I think we can do it. Let's go to original. Always, if you can, unless there's some pretty compelling reason not to, go to your original statement, okay? Because if you go somewhere down further in the steps, you may have made a mistake there. We want to go back to the original. As long as you didn't copy it wrong, that should give you okay. So, negative 10 minus 1. Negative 10 minus 1. Negative 11 times negative 10 plus 9. Negative 1. Negative 11 times negative 1 is positive 11. That works. How about 2? 2 minus 1 is 1. And 2 plus 9 is 11. And 1 times 11 is 11. Yeah, both of those are solutions. That's a quadratic equation. Once you get 2 solutions, stop looking. You found them all. Okay. All right. Any questions before I delete what's here? Okay. All right, solving word problems, the words we love to hear. Okay. A cryptographer needs to arrange 60 numbers in a rectangular array, meaning like that, okay, in which the number of columns, okay, a rectangular array is going to be something like this. Ooh, I didn't do that very well. Okay, that's supposed to be rectangular. This would be a 1, 2, 3, 4, 5, 6 by 3. This would be the rows. I made it 7 by 3. Okay. 3 rows by 7. 3 by 7 by 7 columns. These are the columns, and those are the rows. Okay. So he needs to arrange 60 numbers in a rectangular array in which the number of columns, what do you want to call that? The number of columns. Wait, well, let's go and read it. Number of columns is 2 more than twice the number of rows. Find the number of rows and the number of columns. So what are we looking for? Usually go to the question to determine what you're looking for. It's not a question, it's expressed in the form of a statement. They don't win on Jeopardy. Okay. What happens? What are we looking for? The number of rows and the number of columns. Now you can start out, if you want to, with two different names there, since you're looking for two different things. You want to do that, or you want to think harder? Huh? Start with that. Okay. What do you want to name the number of rows? Say again? N? Okay. Let N, can I call it N sub R, equal the number of rows. Okay, and what would you want to call the number of columns?
C.
Say again? C? Okay, that means yes in Spanish. Okay, so C, so I don't need the sub R, okay? I was afraid if we used N sub R, you'd want N for the number of rows, you might want to use N for number of columns too, so that's right. So C equal the number of columns. You can name them anything you want to, okay? Fred, Sally, whatever, okay. All right, so we've got that done. Now what I suggest is we go to this statement here, in which the number of columns, what's that? C, that's yes in Spanish. So this says C is, how do you translate that into algebra? Is equal to 2 more than, say again? Yeah, 2 more than twice the number of rows. So what would 2 translate as? 2 more than. Say again? Plus, okay? Twice the number of rows. 2 what? 2n? Is that what you said? Number of rows is n. Twice the number of rows would be 2n. Right? Okay, so now we've got the number of columns expressed in the number of rows. Okay? Now, we have a rectangular array, meaning you have so many rows and so many columns. Okay? And we have 60 numbers. What does that tell you about number of rows and columns? Okay, like this one. I have 3 rows and 1, 2, 3, 4, 5, 6, 7 columns. How many numbers are represented here? 21. Because the number of rows times the number of columns equal the numbers. Number of numbers, right? So guess what we have here? You have n number of rows and 2n plus 2 number of columns. So what do we do? Say again? I can't hear you. Okay. You told me here that we had 3 rows and 7 columns. You told me how to get how many numbers were there. How? Someone said it. Someone said 21. How did you get 21? Times the number of rows. So now we have n number of rows and 2 plus 2n number of columns, right? So what do we do to get how many we got? Okay. Plug them into what? What equation? That's what I'm trying to get you to get. Huh? Okay. I couldn't hear that. Okay. You may be saying it right, I'm not hearing well. Plus the number of rows? Yeah. And what's the number of columns? 2 plus 2n. And what do you do to get the total number? Multiply them. Okay, so tell me the multiplication to do. What's the number of rows? N times the number of columns? 2 plus 2n. And how many numbers do we have? 60. Do you see that? Okay. And what do we go from here? Okay, plug what in? I don't understand that. Maybe you're saying the right thing, I just don't recognize it as plugging in. What would you do next? What did we do on the last two problems?
Multiply the n.
Multiply. And what does that give you?
2n plus 2n.
2n plus 2n squared
Equals 60.
equals 60. Very good. Now, one thing I'd like to do, there's two things, maybe several things. But one, I'd like to rearrange it and get it in descending order of the powers. So that would be 2n squared plus 2n. And, yeah, but how about let's go on in minus 60 equals 0. Because we want everything on one side, 0 on the other, because our exponent is 2 or greater. Okay, now what do you notice you could do? What's your next step? Say again? Factor. Sounds like a good thing. What would you factor first? The 2. Okay, and what does that leave you with? N squared plus n minus 30. Okay, and that's equal to 0. Okay, now what would you do next? You've got a couple of options here. What would you like to do? Anybody? Say again? A little louder.
The AC method.
AC method?
Yeah.
We certainly could. I thought you were a proponent of trial and error. This is one with this easy coefficient of 1. Pretty easy. We could do AC. Perfectly fine too. You want to? Just to review it? Why not? What is A times C? Say again? Okay, yeah, negative 30. And what's your B? 1, okay? We want two numbers that multiply to be negative 30, okay? 5 and 6, okay? You already got it. But there are different signs, so which one's going to be the bigger? Say again? 6. So you got a minus 5 times a plus 6. Okay. When you add them together, you get that. Okay. Now, time out a moment here. What I was trying to get you to do, and you're doing it, but don't forget the 2. Okay. You had two options here. Keep it there, which I take is what you're wanting to do. So remember the 2's there. 2 times, and then we rewrite this as n squared minus 5n plus 6n minus 30. Okay? And that's equal to 0. This is using the AC method. What do we do next? Not combine. Or maybe you mean the same thing. Group. Okay? Group those two and those two. Okay? And what you, don't forget your 2. And then what do you have inside the first one? First group. Say again? Okay, yeah, but what do you do with it? Factor out an n. So it'd be n times, say again? N minus 5. And in the second group, plus 6 times n minus 5. Perfect. And that's equal to 0. Okay. And then 2 times n plus 6 times n minus 5 equals 0. That's where we needed to get. Okay. I think what I'm going to do, because this took longer than I thought it would, I'm going to erase my array up here because it wasn't correct anyway. It was just illustration. Okay. And we'll start writing this up here. Okay. So this is the equation we're trying to solve. 2 times n plus 6 times n minus 5 is equal to 0. Okay? How do we go about doing that? Say again? So each one of them is equal to 0. So either 2 is equal to 0 or n plus 6 is equal to 0, or n minus 5 is equal to 0. Okay? Is 2 ever equal to 0? Will you have a question? No. Not. Okay. Now, that's what I was trying to get at to begin with. You could have done this, or right down here, when you first factored out the 2, because this is an equation, you can divide both sides by 2, and you get rid of the 2, and you don't have to hang it around, have it hauling it around everywhere else. But, keeping it like this, now you get rid of the 2. Either way, you get rid of the 2. Okay? Next. Okay, n is equal to minus 6. Is that what you meant? N is equal to negative 6, or n is equal to 5. Okay, and what does n stand for? I forget. Number of rows. So I want you to draw me an array of numbers with negative 6 rows. Huh? Can you do that? No, I can't draw a row with negative. No. This makes no sense physically. Mathematically, it makes sense. Physically, you can't have negative 6 rows. Okay? So this is not a reasonable answer. So n equal 5, that is a reasonable answer. That's the number of rows. So you answered the first question, that's equal to 5. But there's 2 questions here. What's the second one? Number of columns. How in the world do we determine that? Plug it in right back to here. C is equal to 2 plus 2 times, what was that number of rows? 5. And what would that be? 12. So 12 columns and 5 rows. Okay? Does that multiply to be 60? This is real easy to check. Yes, it does. And the number of columns is 2 more than twice the number of rows. Yes, yes, yes. Make sense? Let's see how they did it. I bet you very close to the same way. However, I bet you they use different numbers. They let R be the number of rows. We did that. And then they didn't do the columns. They read that statement here and said the number of columns, they didn't give it a name, is 2 more than twice the number of rows. So 2R plus 2. That's the number of columns. And then they multiply those together just like we did to get 60. And then 2R squared plus 2R is equal to 60. Then let's see what they did next. Subtracted 60 from both sides, just like you did. And then factored out the 2, just like you did. And then factored the rest of it. Now, they did it by inspection, I think. R plus 6 times R plus 5. Got the same answer you did. Okay? They threw away the 2 because you know 2 is not equal to 0. Or you can divide out the 2 and you get rid of it that way. Then you get R plus 6 equals 0, or R minus 5 is equal to 0, R is equal to negative 6, R is equal to plus 5. Both correct mathematically, but for the problem, minus 6 rows make no sense. Solution minus 6 must be discarded, so there are 5 rows, and 2 times 5, 10 plus 2, 12 columns. There's your answer. Okay. Now, let's go back here, and example 8 is here. Another one of these they don't show, and that is a strip of uniform width is cut from both sides and both ends of a 5 by 7 inch photograph. Okay, so on a problem like this, folks, what's your first step? Okay, this is example 8 on page 169. Draw a picture. Okay? A strip of uniform width, if you look at your book, they've got it drawn for you, but I'll do it here. Okay? A strip of uniform width cut from both sides and both ends of a 5 by 7 inch photograph. So let's just call that a 5 and that a 7. Does that look about right to you? My pictures aren't very good. My rectangles aren't very good. But let's call this a 5 by 7 inch. So 5 inches by 7 inch photograph. And we're going to cut a strip of uniform width from both sides and both ends of the 5 by 7 photograph. Find the width of the, and it reduces the area of the photo to an area of 15 square inches. So what's left in the middle is 15 square inches. That's what we're gunning for. So we're going to cut a strip off the end, both ends, and it's uniform, same on both ends. Is this summer? No, not minuet. Got it. Thank you. There you go. Okay. All right. Anyone else come in since the called roll? Okay. And we're going to cut that same width of strip off the top and the bottom. Now, what have they told us? Same width everywhere. And then what's the question? Find the width of the strip to make that a 15 square inch in the middle. Okay? So, guess what I would choose to be the variable? What's the question? Find the width of the strip. So what do you want to name it? W, why not? So let's make this W here, 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 and W that you don't have to write them all in there. But every one of those is dimension W. Okay? And they tell you the resulting area is going to be this. So what is an area? Length times width. So in other words, this new length here times this new width here, I don't want to call that W because we already called that other thing W. These two things need to multiply to be 15 square inches, right? Now, what is this new length here? We know the original length was 7. What have we cut off? Say again? What did we cut off? We cut off a W here and a W there. So what are we left with? 7. 7 what? What are we left with? What's the new length right here? Once we cut off this one and cut off that. I'd say again? You're looking ahead, aren't you? Okay? No, you cut off W's. You cut off one W, that'd be 7 minus W, right? You cut off on both ends, you cut off a W here. You had 7. You cut off a W, you have 7 minus W, right? Cut off another W on this side, you got 7 minus 2W, exactly. So the new length here is 7 minus 2W. What's the new width? It was 5, but guess what you did? Five minus 2W. The new width is 5 minus 2W. Okay? And length times width is 15 square inches, right? So multiply those together. 7 minus 2W times 5 minus 2W is equal to 15. Okay, we'll leave off the units for now. What do we do next? Really not that hard. Curses. What do we do? Say again? We're going to ultimately, but what do we have to do to the left-hand side first? Full it, yes. Okay, what does that give us? 35 minus 14W little louder. Minus 10W. A little louder. Plus 4W squared, right, is equal to 15. All right, now what do we do? Combine like terms, and I'm going to rearrange at the same time. So we have a 4W squared. When you combine your W's, what do you get? Minus 24W. What next? Second? I can't hear. I heard a plus, so I couldn't hear the rest of it. Plus 35. Okay, I can't hear well. Plus 35. What else are we going to do? A little, and subtract. Oh, equal 15. Very good. Okay. Now what do we need to do? Subtract 15. Okay, I thought you might be doing that at first. That's why I couldn't understand what you're saying. I want to make sure I understood. Okay, this will be 4W squared minus 24W plus 20 equal 0. Good deal. Now what? A little louder. I can't hear. Factor it. Excellent. How would you factor it? Say again? You may have said it right. I just don't hear well. Factor out of 4. Excellent. Okay. And what do you have left? W squared minus 6W plus 5 equals 0. Now what? Divide out the 4. I just did it, okay? That would be 1. This would be 0, okay? What do you have left in the inside? Factor that. Only possible factorization for W squared. W times W. 2, and where do you look next? Okay, minus minus, because the last number is positive. They have to be the same sign. The middle is negative. It has to be negative, negative. And you said minus 5, minus 1. Is that what you're saying? Thought that's what you said. Right? Does that work? Okay. So what does this tell us? Right. So either W minus 5 equals 0 or W minus 1 equals 0. What does the first give you? W is equal to 5 inches you're going to cut off, or W equal 1 inch. Thank you very much, Melva. Okay. She already saw it. Figured it out. Okay. Now, if I cut 5 inches off of each side of a 7 by 5 photograph, what do I have left? No, you cut 5 inches off both sides of a 5 by 7 photograph or picture. I don't have anything left. I mean, you don't have 5 inches to cut off here and here and here and here. You can't. So this one makes no sense physically, right? But what if you cut off 1? 1 inch here, 1 inch there, 1 inch there, 1 inch there. What do you have? 7 minus 2 is 5 by 5 by. You cut off here and here. 5 by 3, 3 by 5 photograph. And what's 3 times 5? 15 square inches. There you have it. Cut off 1 inch off. This one makes no sense physically. The other one does. And it checks. Okay? Now, Any questions on that before I delete it? Any? Okay. Pythagorean theorem. Important theorem pertaining to right triangles. If any of you continue on the trig, you'll be doing lots of this. Can sometimes serve as a guideline for solving problems that deal with right triangles. Remember how the Pythagorean theorem goes? A squared plus B squared equals C squared, as long as, what's your A, B, and C? Any requirements there? Okay, well, they sort of is. A has to be one leg of that right angle. B has to be the other leg. It doesn't matter. You can make that A and this B. That doesn't matter. But the C has to be the, anyone know what we call that? The hypotenuse. The side opposite the right angle. Okay? This is the right angle, perpendicular to each other. These, the A's and B's have to be part of that right angle. The C has to be opposite the right angle. Because guess what? What's the sum of the three angles in a triangle? Any triangle. 180 degrees. And if one of them's a 90, what does that leave the sum of the other two? 90. So guess what? Both of these have to be less than that, right? Because this is already 90, the sum of those two have to be 90, so both of those have to be less than 90. Meaning these are the smaller angles, that means these have to be smaller sides than that. That's just all part of geometry and trigonometry. Okay? So the Pythagorean theorem states that in any right triangle, the square of the longest side, called the hypotenuse, C squared, is equal to the sum of the squares of the other two sides, which we call the legs of the triangle. A squared plus B squared. The sum of those squares. Okay? Whoa. Thank you very much for giving it to us and then not doing a thing with it. Let's do example 9. And we will delete all the ink and do example 9. I'm going to read it first. One leg of a right triangle is 2 centimeters more than twice as long as the other leg. The hypotenuse is 1 centimeter longer than the longer of the two legs. Find the length of the three sides of the right triangle. Oh my word. Guess what I would do first? Draw a picture, absolutely. Let's draw a leg, and a hypotenuse, okay? I don't know if those are anywhere close to reality, but we're going to start with that, okay? Now, what we have here is a hypotenuse. You want to call it H or C or whatever else you want to call it. You choose, huh? H, okay? Let's call it H. Now, we have two legs. I drew them so one's a short leg and one's a long leg, so it walks funny, okay? So, what, you want to name those anything special? A and B. Which one you want to be A, the long or the short? Short. Okay, we're going to have A being the short leg and B being the long leg. Now, what do we know about right triangles? You can tell me that right now. Well, let's stop. Let's wait there. Let's read what they said. One leg of a right triangle. Okay, I should have written this down. Let me write it. One leg of a right triangle, that stands for triangle, is 2 centimeters more than twice as long as the other leg. Okay? The hypotenuse is 1 centimeter longer than the longer of the two legs. 1 centimeter longer than the longer. of the two legs. Find the lengths of the three sides. Okay, we kind of already done that, okay? One length is A, one's B, and one's H, okay? But we need numbers there, okay? So let's start with that first sentence. One leg of a right triangle, okay, is 2 centimeters more than twice as long as the other leg. Now, which you reckon is the one leg and which you reckon is the other leg? If one leg is 2 centimeters more than twice as long as the other leg, which would that be, the long or the short? The one leg. Huh? B. The one leg is B. Okay, so let's plug that in. B is, what does that translate as? Equal to, more than, plus, twice as long as the other leg. 2A, you got it. B is equal to 2 plus 2A. Okay? How about hypotenuse? What would that be? H is equal 1 plus, which is the longer of the two legs? B, you got it. Okay? So here's one sentence. B is equal to 2 plus 2A, and H is equal, 1 plus B. Okay. Got a little carried away with my circle there. Okay. Now, what do we know about right triangles? The Pythagorean theorem, is that what someone said? Oh, 90 degrees. Okay, yeah, I understood. Okay. So what do we know about these three sides? What relationship ties them all together? Say again? We just said it, I thought. Y'all told me. Pythagorean theorem. And how does it go? H squared is equal to? What do you say? A squared plus B squared. Okay. Now, our A was the shorter leg. Okay. We don't know beans about that, so that's just going to be A squared. But we do know what H squared is, or what H is. H is 1 plus B. But then, of course, B is, so let me do a little more figuring here. I'm going to take off my circle because that's in the way a little bit. We already know what B is. So H is equal to 1 plus 2 plus 2A, right? Isn't that what we said here? 1 plus B, but B was 2 plus 2A, right? So what would H be? 3 plus 2A. Okay? So H squared would be 3 plus 2A squared, right? Is equal to A, we don't know beans about it, so just write A. A squared plus, but what is B? 2 plus 2A. 2 plus 2A squared. There we have an equation. All the variables are A. I think we can solve that one. What do we do first? It must be Monday. Say again. Not factoring. You got to multiply or square it, right? Remember how you square a binomial? Help me, help me. How do you square a binomial? You can come to the side and write it down as 3 plus 2A times 3 plus 2A. That's one way to do it. Does anyone remember the shorter way? If not, we can do it this way. How do we do this? Say again? FOIL it. Very good. How does that give us? 9 plus, second, 6a plus 6a plus 4a squared. So that gives us 9 plus 12a plus 4a squared. Okay, so that's what this side is. I'm going to rearrange it and do 4a squared plus 12a plus 9 is equal to, over here we have an a squared plus, and by the way, now do you remember what the shorthand was? Square the first, square the last, oh, I got it back. Square the first, square the last, and twice the product of the two. The product of the two is 6a, double that, you get 12. Yeah, that's what we do. So you want to try that here, or you want to go over here and multiply it out again? Up to you. I really don't care much. What do you want to do? How do you square that binomial? You tell me what to write. 4, okay. Plus 4a? Okay, 4a squared, I'll buy that one. What's the other term? 2 times 4a, which is? Huh? I can't hear it. No, it's not 4a, it's twice the product. Remember? So that would be 8a. Okay? If you'd rather do the following, follow it. If it keeps you from making mistakes, do that. All right, now here we have an equation. Now there may be a tendency to combine like terms on both sides, and usually that's a very good idea to do. However, I notice there's a 4a squared over here and a 4a squared over here. I can just subtract them away and make this appear, right? So let's do that. It's a little simpler, keeping the numbers easier. So let's start with doing minus 4a squared, minus 4a squared. These go away, and you're left with, let's start with this side. A squared, and let's subtract 12a from both sides to get everything on the side with the a squared, and let's subtract 9 from both sides. Okay, so it'd be a squared, and when you do plus 8a minus 12a, what does that give you?
4a.
Minus 4a. Okay, and when you do 4 minus 9, you get a minus 5, and that's equal to 0. So what might we do next? You might close the door. I don't know. Okay. What do you do next? Say again? Maybe factor it? Is that what you said? What was the a times a? Very good. Where do we look next? Sign of the last term is negative. That means these two terms have to be different. So which one you want to put where? Plus and minus. Now, two numbers that, because they're different signs, multiply to be 5, but their difference is 4. 5 and 1, okay? And which one wins the, which sign? Huh? Say again? Plus 1, negative 5, you got it. And that's equal to 0. Okay, and what does this tell us? Okay, so either a plus 1 is equal to 0, or a minus 5 is equal to 0. Okay? The first one does what? Subtract 1 from both sides, and that gives you a is equal to negative 1. Okay? Or add 5 to both sides, and that gives you a is equal to 5. Okay? Now, I want you to draw me a triangle with a short side of negative 1. Don't think you can do that. Okay, so the a equal negative 1 isn't going to work very well, is it? Okay, but A equal 5. I don't think they had any units in these. They just said, so the short side, A is equal to 5 units. Okay? But it said find the length of all 3 sides, right? Find the lengths of the 3 sides. So which one would you go for next? We have here that B is equal to 2 plus 2A, right? That's from up here. So that would be 2 plus what? Which is 10, so that would be 12. B is 12. And then what do we know about H? 1 plus B, which would be 13. Okay, real easy, good way to check it. Pythagorean theorem. 5 squared is 25, plus 12 squared is 144. So 25 plus 144 is, write it down if you need to, 169. What's the square root of 169? Ding, 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 ding. Yes, it is. 13. Very good. So you've done it. All right. Good deal. That's what they got to. That finishes 3.7. Okay. There's some true false, 3 of them, concept quiz. Good idea to look at those. Their answers are at the end of the problem set, so I would do those. Then homework exercises, do any of the odds 1 through 53. There's a whole passel of those. And then do any of the word problems 55 through 69. Okay? Quite a few of those. You probably don't want to do them all, but do as many as you can. And the answer to the concept quiz is there. Everybody's got a copy of the quiz. Some of you have already turned it in. Please get those in either Wednesday or Monday. Okay? I'll give you till Monday if you need to. Okay? We still got a little bit of time. Where we go now is jump over to chapter 6. Now that seems sort of crazy, and part of it is a little crazy. And chapter 6 starts with complex numbers. Okay? Why is this not advancing? Okay? Maybe because I was hitting the wrong thing. Okay, I was hitting the wrong thing. All right. We got 5 more minutes or 3 more minutes. Let's at least get started here. Okay. So let me explain what we'll be doing here, if I can get it to go back. Okay, here we go. See what the title of chapter 6 is? Quadratic equations. That's what we've been dealing with, isn't it? So why not go on and do this since we've just been dealing with it? Okay, we'll go to PowerPoint lectures. Now, I'll take the rest of the time today with 6.1, though we're not going to do it. And I think I told you this at the very beginning when I was going over the syllabus. There's nothing in the course description that says we'll do anything to do with, come on up here now. Oh boy, this is going to take forever. Complex numbers. Okay? Does anyone know what we mean by complex numbers? Okay. There are 2 things so far we've talked about that you can never do. I think we've talked about them. One is you can never divide by 0. Well, guess what? Still can't divide by 0. The second of those, does anyone remember what that thing is? It is to take a square root of a negative number. Okay? What complex numbers allow us to do is to take a square root of negative numbers by introducing this one funny little number called I. It's not a real number. It's an imaginary number. Okay? And it's the number I. So you get down to this. I'm not going to go over all this, but I squared is equal to negative 1. So therefore I is the square root of negative 1. Okay? So it's a brand new number. It's an imaginary number. It has no value, but it allows us to do that. That's what a complex number is. It's some combination of a real number A plus some other real number b multiplied by that imaginary number I. And in this, now you can take any square roots you want to, positive or negative. If they're negative, you'll wind up with some imaginary parts. We're not going to do that. The only reason I'm showing you this is that in some of the exercises in this section, not this section, the next section, are going to pop, those are going to pop up every now and then. When they do, ignore them. Just skip and go to the next problem, okay? So we're not going into this. If you want to look at it, you certainly can. You may hit it in future classes, but generally it's not something we do in this course. I will show you one thing, though, okay? When you have, usually you write it A plus BI, okay? But if you had it something like this, A is 2/3, that's a real number, plus B, the square root of 2 times I, they wrote the I in front. A very good idea to do, because if you wrote it this way, it's hard to see whether the I is under the radical or not under the radical. So it's usually a better idea to write the I in front of the radical, just so you know it's not part of the radical, okay? But we're not going to be doing any, so don't sweat it. But in future courses, further courses, you can. So we'll be starting next time is 6.2, okay? And 6.2 is going to look almost just like what we were just doing, okay? And then from 6.2, we'll do 6.3, and then we'll do 6.4, and we'll be ready for our test, okay? So we'll start next time with 6.2. Thank you so much. All right.